Hi, ladies and gentlemen, welcome back. I am so happy to see you again. My name is Mrs. Hoffman, in case you have forgotten. Today for our math lesson, lesson number 7. Guys, we've done so much math. You're gonna need just a couple of things. You're gonna need your student guided practice page. It's the one that says the word variable on it. That's a new vocabulary word we're gonna talk about today. And then you need that pencil that has an eraser on it, because remember, sometimes in math we make mistakes and we have to go back and check our work, just like we did on our last time when I thought I had a problem wrong. So grab those two things for me, and while you're doing that, we're going to think about doing just a quick refueling break to get our brains and our bodies ready. Today we're going to do that 5-finger breathing again. We've done this before. All you need is just that one hand, or you can follow along with me. We're going to take big breaths in when we go up our finger, and then we're going to take nice deep breaths out, or let them out when we come back down. We're going to do that 2 times around our hands. All right, are you ready? Sit up nice and tall. We're going to take some big deep breaths in. Here we go. Big deep breath in, and then let's let it out. Another big deep breath, and let it out. Real big deep breath in, let it out. 2 more on this hand. 1 big deep breath in, and let it out. Last time, big deep breath in, and let it out. We're gonna do that one more time to really get our brains focused, and I want you to turn that math brain on, because it's gonna be a tough day today, but I think we can get through it. Here we go, one more time around our hand. Big deep breath in, and then let it out. Again, big deep breath in, let it out. Make this your biggest breath. Here we go, big deep breath in, and let it out. Another one, big deep breath in, and let it out. Last time, here we go. Big deep breath in, and let it out. There we go. All right, now I think our math brains are turned on and ready. Let's see if we can learn about some new words today. Our goal is to solve real world problems using symbols for unknown numbers. So we've done this before. We used a question mark as our symbol, but today we're going to use something called a variable. This is the word variable. Say that word, variable. Great job. So a variable is just simply a letter that goes in place of a number, or sometimes it's a symbol, like when we use that question mark. So take a look here. I had a problem similar to this last time, but the numbers were much bigger. This one says 3 plus question mark equals 7. Well, we know that question mark isn't a number. It's just a symbol that represents a number. So if I was going to solve this problem, I would be thinking in my head about those fact families that I know. And then I would also be thinking about what simple facts I already know. I know that 3 plus 4 equals 7. So in this case, that question mark represents the number 4. So I could take my pen and I could write question mark equals 4. So that when I put a 4 in place of that question mark, my number sentence says 3 plus 4 equals 7. So we used a question mark last time as our symbol to represent our unknown number. But today we're going to use a letter. Now, a letter can be any letter in the alphabet, A through Z, any letter that you want. Capital letters, lowercase letters, your choice. We're just going to use that letter to represent, again, a number that we don't know. So here I've used 12 minus R equals 4. So what's the variable in that problem? Is it the 12, the R, or the 4? Perfect, it's the R. So this is my variable. And remember, that variable just represents my unknown number. So in your head, let's think about this. 12 minus some number equals 4. Are you thinking 8? Yeah, me too. So I could say R equals 8. So when I put that 8 into my number sentence and replace that R with 8, it says 12 minus 8 equals 4. Does that make sense? Perfect. So here's our big question. How are variables going to help us solve real-world problems? How can we use variables to help? Well, let's take a look. Look at this first problem here. This is about 3rd graders and 4th graders. So you guys have just finished 3rd grade and you're getting ready to go to 4th grade. So 3rd and 4th graders are going to go on a field trip. Doesn't that sound like fun? There are 363 students that are going all together, and 157 of them are third graders. So our question is, how many fourth graders are going to be going on our field trip? So let's think about what we did last time. Last time we used a bar diagram to help us solve problems. Let's start with that because we already know. So I'm going to draw my bar diagram here. Remember, I'm going to split it in half. Do I know the total number of students going on the field trip? Yep, I sure do. There are 363 students. So remember, in our bar diagram, the total number goes on the top here. 363 students. Now, I know also how many students are third graders. Look at our problem. How many students are third graders that are going to go on our trip? Yeah, 157. So I'm going to put 157 here, which means this is my unknown number. So last time we used a question mark in that spot, right? And from here, we would have then written our number sentence to help us solve this problem. So let's write it using our question mark, and then we're going to replace that question mark with a variable. So I know that if I take my two parts and I add them together, I'm going to get my total, correct? So I know that this must be a subtraction problem because I already know my total. So we're going to start with our total, 363. Let's put that here. We're going to take away the number of third graders. That's 157. And that's going to represent our question mark, our number of fourth graders. So let's think of a letter that we could use to represent fourth graders. Well, I don't want to use a number like 4, so I have to be really careful to think about a letter. So I'm going to use the letter F because fourth grade starts with the letter F. So I'm going to put an F here. So there's my variable. That's my unknown number. Do you remember how to solve this problem to find out what that unknown number is? Yeah, we have two options. We can either use an open number line or we can use base 10 blocks. Since I don't have a lot of space here, I'm going to use an open number line to help me solve this problem. So I'm going to think back to what I know about open number lines. I know that it's going to be a big long line with an arrow on both ends. I know that it's going to start with my small number, 157, and it's going to end all the way over here with my big number, 363. Okay, so I need to find a friendly number that's close to 157. So I think I'm going to jump to 160. How many jumps did we make there? Good, 3. We went 3 jumps. Now I've got that even 10 there, that's 60. So I want to go from 160 to 200. That's going to be my next jump. Let's count by tens and see how many tens it takes us to get from 160 to 200. Are you ready? I'm going to count my tens. Here we go. So 160 is where I'm starting, 170, 180, 190, 200. How many tens did we jump? That's right, 4. And so we know that 4 tens is the same as 40. So I'm going to put that 40 here. Now where do I want to jump from? I'm at 200. Where should I go next? Perfect. I'm going to go all the way to 300. So to go from 200 to 300, you know that one pretty simply. We're going to jump 100. Great job. I'm almost there. Let's go to the closest friendly number to 363, because remember, we're going to keep all those tens and ones apart. So I'm going to go to 360, which means I went from 300 to 360. That's going to be 60. And then I just have 3 more to go. 360 to 363. Man, now what do? I have to think back to that commutative and associative property so I can add all those together. So let's take our numbers here and let's reorder them. I'm going to put my hundreds together first. I'm going to stick mine right in here. So I'm going to take my 100, I'm going to put it here. Let's see, how about my tens? I've got a 40 and a 60. So I'm going to put those together. And then how about our ones? I see a 3 and a 3. Let's put those together. Whoops. Okay, so now I've used my commutative property to reorder my numbers. What does the associative property do? Do you remember? Yeah, it says we can group numbers together. So let's do that. I just have one single 100 here, so I'm going to leave that be. But I'm going to group my tens. I'm going to group my ones. Okay, so now let's think about this. I'm going to erase some of my problem down here so I've got room to write. Sometimes I run out of room on my board. Okay, so I've got 100. Let's add 40 plus 60. Okay, well, let's start with our big number 60 and let's count 4 tens. So 60, 70, 80, 90, 100. There's another 100. And then let's add our ones together. 3 plus 3, you know that one, is 6. Perfect. Let's push them all together. So 100 plus 100 is 200. Plus 6 is 206. So our problem, 363 minus 157, tells us, whoops, that should say 6 right there, that 206 of our students are 4th graders. So think about all the math that we just used. We used our bar diagram. We used a variable. We used an open number line, the associative and the commutative property all in that one problem. You guys did a great job. Let's try another one. Okay, here we go. We've got 3rd graders and 4th graders again. It's like there's a big contest. The 3rd grade class collected 325 cans for the food drive. The 4th grade class collected 137 cans. How many more cans did the 3rd grade class collect than the 4th grade class? So let's think about what we know and think about what we need to figure out. What do we know? Yep, we know that the 3rd grade class collected 325 cans and the 4th grade class collected 137 cans. So who collected more? That's right, the 3rd grade class. So if I want to know how many more the 3rd grade class collected, am I doing addition or subtraction? Perfect, I'm doing subtraction. And the thing that I don't know is how many more cans we collected. So let's write our number sentence. Let's see. I'm going to pull this out of our way. Get that out of the way because we don't need that right now. All right. We know that the 3rd grade kids collected 325 cans. That was more than the 4th grade who collected 137 cans. So if I take the number of cans the 3rd grade collected and take away the number of cans the 4th grade collected, that will tell me how many more cans 3rd grade collected than 4th grade. So what letter can we use to represent cans? Are you thinking C? That's what I'm thinking. I'm going to put a C here. Remember, you can put any letter you want. This is called a variable, and it just represents a number. Okay, so now let's solve this problem. I'm looking for what number represents C. So I can use an open number line again, or I can do some drawing. What are you thinking? Okay, let's do an open number line again. That's what I'm going to use. I'm going to start down here with 137, and I'm going to end all the way over here with 325. It's a lot of math, isn't it? But we can do it. All right, 137, the next closest friendly number, is going to give me 140. I'm going to jump 3. I want to go from 140 all the way to 200. So count with me by tens. We're trying to get to 200. So I've got 140 in my head, 150, 160, 170, 180, 190, 200. How many tens did we jump? 6. So that's going to be 60, right? So here we go. All right, now I'm at 200. How do I get to 300? Perfect. I'm just going to jump all the way over here to 300, and you know that that's 100. Okay, let's go to 320. To go from 300 to 320 is just a simple jump, of 20. And then from 320 to 325, that's another simple jump of 5. What's our next step? Yeah, we want to use our commutative property to rearrange our numbers and make them easier to add. So we're going to start with our hundreds. So I've got 100. I'm going to do my tens. I've got 60 plus 20. And then I'm going to do my ones. I've got a 3 and a 5. And remember, order doesn't matter just yet. That's why we're using our commutative property to help us. Let's use the associative property and let's group those numbers together. We only have 100, so we're going to leave that alone, but let's group our tens. And then let's group our ones. Let's add those together. Okay, so I have 100 What's 60 plus 20? So let's think in our heads. I've got 60, I'm gonna go up 20. So 60, 70, 80. And then really quickly in your head, 3 plus 5. It's gonna give you 8. There you go, let's add those together. 100 plus 80 plus 8 is 188. So our students, our third graders, collected 188 more cans than our fourth graders. Great job, third grade. That was a tough problem, wasn't it? That was really hard, but I think that you can do this. Let's do one more together real quick, and then I'm gonna have you try one all on your own. Let's see. A school bought 763 pencils in 2 months. That's a lot of pencils. I feel like we might need that many though. It bought 257 pencils in the first month. So how many pencils did it buy in the second month? Ooh, let's see, what do we know? We know that altogether they bought how many pencils? That's right, 763. Let's use our bar diagram. So altogether, 763 pencils. How many did they buy in the first month? That's right, 257. Instead of putting a question mark here on this one, let's use a letter to represent what we don't know. What we don't know is how many pencils they bought in the second month. So we're looking for how many pencils. Well, what letter could we use to represent pencils? Yeah, we could use a P. Be careful. Make sure your P goes the right direction and that it doesn't accidentally look like a 9. Sometimes that can get very confusing. All right, so I know that I have my total, which means that I must be doing a subtraction problem. So I've got 763 pencils minus 257 pencils. Whoops, I said 257, but that is not what I wrote. 257 pencils equals the number of pencils they bought in the first month or second month. Well, let's this time, since we've already used an open number line, let's draw our problem this time. 763 is what I'm going to represent using my base 10 blocks. So let's do that. I'm going to start over here with my hundreds. Looks like I need to draw 7 of them. Do you remember what you draw when you're making 100? Yeah, that big flat. So let's do 7 of those. 1, 2, 3, 4, 5, 6, 7. I've got 6 tens. So remember, we're going to draw 6 rods. 1, 2, 3, 4, 5, 6. And then I'm going to draw 3 ones, 3 units. So 1, 2, 3. Okay, I'm going to take away 257. Are you noticing a little problem? Yeah, I only have 3 units, but it wants me to take away 7. So do you remember what we have to do to solve that problem? Yeah, we have to borrow, don't we? So let's take one of these rods and let's bring it over here. It was a 10, which is 10 single units together. So let's just re-represent those over here as 10 single units. Be careful, don't count those 3 you already have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now can I take away 7? Yeah, sure I can. Let's do that. Let's cross them out. 1, 2, 3, 4, 5, 6, 7. Well, how many does that leave us up here on top? 1, 2, 3, 4, 5, 6. It's going to leave us with 6 ones. I'm going to put that right down there. Okay, I've got 10s here and I need to take away 5. Do I have 5 10s that I can take away? I do. I have exactly 5. Here we go. 1, 2, 3, 4, 5. How many 10s are left? That's right, 0. No 10s are left. All right, do I have 200s I can take away? Absolutely, here we go. 1, 2, how many hundreds are left? 1, 2, 3, 4, 5. So let's take that number, put it all together. If I do 763 minus 257, I'm gonna get 506. So in this case, our school bought 506 pencils in the second month. They must have figured out that kids use a lot of pencils. I bet it was those erasers that disappear out of nowhere. What do you think? I bet so. All right, take a second. I want you to try this one on your own. I want you to be really careful. It says Christian scored 346 points in the first round of his video game. I bet that you guys can probably relate to this problem. In the second round, he scored 268 points. So how many total points did Christian score in his video game? So think for just a minute. Do you know the total? Are you adding or subtracting? And what method do you want to use to do that problem? Take a moment and see what you can do with this problem. All right, guys, I know that this is a really tough problem and there's a lot of work here, but let's see how you did. Did you notice that on this problem, you don't know the total? So if you drew that bar diagram, then you were able to fill in both sections on the bottom with 346, goodness gracious, and 268. But what you don't have is the total number of points that he scored. So what I'm looking for is how many points, which means this is an addition problem. So if I do 346 plus 268, that will tell me how many total points Christian scored. Did you set your problem up like this? I hope you did, but if you didn't, that's okay. We can use our eraser and go back and fix it. So I think I'm going to use base 10 blocks to add these together. Let's see. I think I'll start by doing 346. So I know that I'm going to draw 300. I know that I'm going to draw 4 10s. And I'm going to draw 6 1s. 1, 2, 3, 4, 5, 6. Now I need to represent that second number, so I'm going to draw 268. So I'm going to draw 200, and when we did this before, we made these different colors, but it's okay to just use your regular pencil and do it too, because we're just going to combine these numbers anyway. We're going to draw 6 10s, 1, 2, 3, 4, 5, 6, and then I'm going to draw 8 1s. 1, 2, 3, 4, 5, 6, 7, 8. Now when I add them all together, all I have to do is count. But I think I noticed something down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Don't I have enough there to make a 10? I do, so watch this. I can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 right here are the same as 1 10 here. So I'm actually going to grab that and I'm going to bring it right over here and draw it like this. So now I'm done with all of these. How many units do I have left here? 1, 2, 3, 4. 4. So I just re-represented. This was 14 and now I turned it into an extra 10 and a 4, and that's the same as 14. Well, let's count this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I can take all of these and make them into a flat, into 100. So now I don't want to count these. How many 10s do I have left? Just 1, so there's 10, right? Now how many hundreds are there? 1, 2, 3, 4, 5, 6. 600. So if I add all these together, 600 plus 10 plus 4 is going to give me 614. So how many points did Christian score? That's right, P equals 614. Great job. Okay, so for an extension activity today, this is a really fun one. I'm sure that you've done task cards in your classroom before. Task cards are simply just small pieces of paper that have a problem on them. In my classroom, sometimes we play Scoot or we do partner activities with them, but you're gonna make your own. And the way you're gonna do that is you're gonna take just a piece of paper and you're gonna cut it in half. On the front, you get to make up your own word problem. I want you to challenge yourself and use those bigger numbers. You're gonna make up your own problem. On the back, you're gonna solve that problem using the methods we used today. Then you're gonna give those problems to your friend or to your parents or to your siblings and see if they can solve them and get the same answer that you did. Whatever you do, have fun, and we'll see you really soon. Our code word today is going to be tiger. Have a wonderful day, guys, and I'll see you next time. Bye.